Okay, so today we're talking about something that honestly sounds like it's straight out of science fiction. We're talking about an AI that can forecast your future health, predicting if you're going to get sick years before it ever happens. It's an absolutely breathtaking leap for medicine for sure, but it also opens up this whole can of worms, right? Like, what happens when we can see our medical destiny? And who exactly gets to hold that crystal ball?
Let's just bring this home for a second. Imagine a tool that could tell your doctor you're at high risk for heart disease, not next month, but 10 years from now. Seriously, think about that. How would that kind of knowledge change everything for you right now?
And listen, we're not talking about just a handful of conditions here. These groundbreaking new AI models, one of the big ones is called Delphi 2M, well, it can forecast an individual's risk for over 1,000 different diseases. 1,000! The sheer scale of it it's staggering.
And if that number wasn't crazy enough, the time frame is what really gets me. This isn't some short-term forecast. No, the AI can look a full decade into the future, 10 years. That gives us this massive window to actually prevent illnesses in a way we've just never, ever had before.
All right, so here's how we're going to break this all down. First, we'll look at this AI crystal ball itself. Then, we'll get into how it actually makes these wild predictions. After that, we've got to tackle the big ethical questions. We'll also see what it takes to get this stuff out of the lab and into a real clinic. And finally, we'll talk about how we can actually forge a better, healthier future with this tech.
So, let's start with the big picture. What is this AI crystal ball, really? Well, you can think of it as a total game changer for medicine. We're talking about a fundamental shift from being reactive, treating you when you're already sick, to being proactive, to stopping an illness in its tracks before it even begins.
So here's kind of the magic behind it. This predictive AI basically digs through these massive piles of data. I'm talking medical records, your genetics, lifestyle info, the whole shebang. And it finds these tiny, subtle patterns that, honestly, no human doctor could ever spot. And the entire goal is to build a unique, personalized health forecast just for you.
Okay, that all sounds pretty incredible, but how powerful is it really? And maybe the bigger question is, can we actually trust what it's telling us? Let's dig in and decode these predictions. I mean, the range of what this thing can look for is just huge. It can flag risks for all those major chronic diseases that are such a massive burden on our healthcare systems, heart disease, diabetes, cancers. But it also gets into the likelihood of mental health conditions like depression and anxiety, and even those really devastating neurodegenerative disorders like Alzheimer's. And here's the so what. Why does predicting those diseases matter so much? Well, get this. Over 90% of all of our healthcare costs are tied to treating these exact chronic conditions. Just let that sink in for a second. Imagine the monumental impact on our health, on our economy, if we could actually get ahead of them.
All right, so let's talk numbers. How accurate is this thing? When they put it to the test on a massive public data set, we're talking millions of real patient records, these models hit an accuracy rate of over 91%. Which, look, that is remarkably high. But, and this is a big but, accuracy alone doesn't tell the whole story.
Yeah, to really get it, you have to look at a couple other things called precision and recall. So think of it like this. High precision means that if the AI raises a red flag and says you're at risk, it's very likely to be right. It's not crying wolf. And high recall means it's really good at catching most of the people who genuinely are at risk, so very few cases slip through the cracks. For a tool like this to be truly useful, you absolutely need both. But okay, with all this incredible, world-changing power, you know what's coming next, right? A whole lot of really difficult questions. And this is where the conversation starts to get tricky. It's like a two-sided coin, On one side, you have this almost utopian promise, prevention that's tailored just to you, interventions that happen years earlier, a way more efficient healthcare system. But you flip it over, and the perils are just as profound. We're talking about biased algorithms, huge risks to our data privacy, and the very real danger of making healthcare even more unequal. So let's really unpack these ethical landmines. For starters, data privacy. Who owns and protects this deeply personal information? Then there's the massive issue of bias. If an AI is trained mostly on data from one demographic, it can be way less accurate for others, creating real health disparities. And here's a huge one. Will this technology just become a luxury item, widening the gap between those who can afford predictive care and those who can't? And even if we could solve all those tough ethical questions, and that is a big if, there's still this giant practical roadblock. How do you take this amazing tech that works perfectly in a lab and make it work in the messy, chaotic reality of an actual hospital?
And this gets at a really well-known problem in medical AI. They call it the implementation gap. See, in the clean, controlled world of a research lab, an AI can look like a superhero. Its performance is off the charts. But the second you deploy it in the real world, the actual benefit to patients can often just plummet.
And we're not talking about a small dip either. A major review found that a stunning 44% of these predictive AI tools, despite all their promise, end up failing to produce any meaningful benefits for patients once they're actually put into practice. 40%! So, what gives? Why is that happening?
Well, it turns out there are a few key reasons. For one, real-world hospital data is, well, it's a mess. It's often incomplete. Then you've got the black box problem. A lot of these AIs spit out an answer, but doctors have no idea how they got there, which makes it really hard to trust. And then there's the human factor. Clinicians can get what's called alarm fatigue. If a system generates too many alerts, they eventually just start tuning them out, even the important warnings.
So, knowing all of these challenges, where do we go from here? How do we harness this technology's incredible promise while carefully managing all of its very real risks?
The path forward really seems to require a three-pronged approach. First, we need strong, modern regulations designed for the AI era to protect our data. Second, we have to crack open that black box and insist on tools that make AI decisions transparent and understandable to doctors. And third, and this is crucial, we have to make equity a priority right from the very beginning, training these systems on diverse data and constantly checking them for fairness.
Ultimately, when you step back, this technology is offering us a brand new map for navigating our health. And the challenge for all of us, for the developers, the doctors, the regulators, and for us as patients, is to make sure that the routes on this map are open to everyone, and that they lead all of us toward a genuinely healthier future.